Our team researched the Council House 2, also known as CH2. It is an office building located at 240 Little Collins Street in Melbourne City Centre, Australia. Council House 2 is a 10-story office building for about 540 City of Melbourne staff. It has a ground floor retail spaces and underground parking, which was officially opened in August 2006. It became the first purpose-built office in Australia to achieve a maximum 6 Green Star rating, certified by the Green Building Council of Australia. This is a rough equivalent to LEED Platinum in the United States. It has been designed to copy the planet's ecology using the natural 24-hour cycle of solar energy, natural light, air, and rainwater to power, heat, cool, and water the building. Council House was designed by Design Inc. Group and structural engineering by Bonazzi Group. Construction type is 2B with 134,000 square feet floor area. Comparing to a building with 5 Green Star rating, Council House 2's emissions will be 64% lower. When compared to the existing Council House next door, it is expected to reduce electricity consumption by 85%, reduce gas consumption by 87%, and produce only 13% of the emissions and reduce water main supply by 72%. Council House 2 also features 48 meters square of solar panels, which provide 60% of hot water, as well as gas-fired cogeneration plant, which provides 40% of the building's overall electricity, with reduced carbon emissions. Of the total construction cost of $51 million, $12 million were invested in energy, water, and waste innovation. The time for payback is expected to be less than 10 years. Because the building is located in the southern hemisphere, or the South Temperate Zone, it is exposed to more direct sunlight during November, December, and January. The winter season comes during June, July, and August. The sun rises in the east and moves across the northern sky. Unlike the northern hemisphere, the sun moves from right to left. Council House 2 is geographically located in the southern coast of Australia. It is located 40 miles away from the Southern Ocean. The building is also in the heart of Melbourne City Centre. It is in an area of Melbourne in Victoria, Australia. The underground floor is programmed with parking lot, housing 20 car parking spaces and 1 parking space for disabled, 80 parking spaces for bicycles, 9 shower rooms for cyclists. Retail stores and lobbies are located on the first floor. The second to the 10th floor is Government Workers' Office. It's a roof terrace on the top of the building. Melbourne falls under the moderate oceanic climate according to the Köppen classification and is well known for its changeable weather conditions. This temperature differential is most pronounced in the spring and summer months and can cause very strong cold fronts to form. These cold fronts can be responsible for all sorts of severe weather, from gales to severe thunderstorms and hail, large temperature drops, and heavy rain. These showers are often heavy and can contain hail and squalls and significant drops in temperature, but they pass through very quickly at times with a rapid clearing trend to sunny and relatively calm weather, and the temperature rising back to what it was before the shower. This occurs often in the space in minutes and can be repeated many times in a day, giving Melbourne a reputation for having 4 seasons in one day. The sun positions at 9 a.m. and 3 p.m. in Melbourne in midwinter. The wind direction is different by season. In winter, the wind comes from the continent, while in summer, the wind comes from the sea, from the south. CH2 has been designed to be a highly energy efficient and sustainable building, with all its systems and spaces forming an interconnected and interrelated whole. Much like a living organism, the building requires all of its limbs and organs to fully function. The elements of the thermally efficient design concept for CH2 are stimulated by the termite mound. In a termite mound, the cool wind is drawn into the base of the mound via channels, and the coolth is stored using wet soil. As the air warms, It flows upwards and out of the mound via chimney. The termite mounds are able to keep a stable temperature within, allowing the termites an ideal temperature for harvesting despite the large variations in temperature outside. In CH2, the cold air is drawn into the building via south stacks. The coolth is stored in the mass ceilings. When the air is warmed, it is drawn outside via the north stacks. The horizontal as well as the vertical form of CH2 was developed by the example of skin, composed of epidermis, outer skin, and dermis, the inner skin. Conceptually, this notion developed into the facade, becoming analogous to an inhabited skin or a traditional veranda. The epidermis translated to the outside zone to house the stairs, lifts, ducts, balconies, sunscreens, and foliage, with the inner line defining the extent of the fire compartment. All structures within the dermis were to remain lightweight and steel-framed. The outer epidermis, compared to the hair of the skin, provides the microenvironment, including the primary sun and glare control for the building, while helping to create a semi-enclosed microenvironment for the user's outlook. Inspired by the aesthetic and function of bark, which protects and houses the tree, the eastern facade houses the service core and toilets to the building. The bark facade was conceived as a second skin, or protective layer, assisting with the natural ventilation of the wet area spaces. The final solution consists of two overlapping layers of perforated metal with polycarbonate walling and fixed metal louvers. Another innovative concept of the design of CH2 is the provision of the same amount of foliage on the building as would have been present if the site was still in its original natural vegetated state. The roof garden, together with the planter boxes on the northern facade, meets this aim and provides a microclimate for various building spaces. The roof garden is a large space for use by the staff in the building as a breakout space and for recreation. The passive and active climate control system is highly integrated with the building structure systems, especially the vault ceilings. The Council House 2 also has very comprehensive and effective facades strategy, which contributes to the climate control and lighting. This diagram shows the system of a typical floor of Council House 2. The columns and shear walls provide vertical support. Then, vaulted precast concrete panel is placed on top of it. Metal panels are used to cover the gaps between the panels, and then upper floor and beam shear casted on top of it. The shear walls, assisted with columns and beams, forms the main structure of CH2. There are 3 rows of columns with a distance of 14.24 and 6.11 meters. Each row has 4 columns with a distance of 8.2 meters between each 2 of them. The shear walls in the east part of house the service space and help to make the whole structure system stable. The diagram shows the construction process of CH2. The ceilings are made of precast concrete with a wavy shape to optimize surface area, which allows for an increase in the thermal mass capacity. Fresh and cool air comes from the diffusers in the floor and chilled beams. The space inside the ceilings and also the thermal mass of concrete slabs store the heat at day and cool at night. The air is warmed in the office space and then returns to the north stacks via the hollowed ceiling panels. Here are the construction details of the ceiling. The precast concrete panels are placed directly on the columns. Then, use metal panels to cover the gaps between it. And finally, cast upper floor and beams on top of it. This is the moment diagram of gravity loads, which shows the vaulted panel is structurally effective. The strategies for 4 facades are all distinctly different. From left to right, they are west, north, east, and south facade. The western elevation is bioclimatically responsive to the direct sunlight falling on the facade. The facade is controlled by the building management system, informed by a solar clock and the weather station on the roof. The facade movement is controlled by the building management system with a software program set to the sun's movement throughout the year, for example, a solar clock. This automated system provides the ability to optimize the lighting-cooling balance, including dealing with difficult low sun angles in winter. On the southern facade, tapering window to avoid heating on the upper levels is designed. There are also several shower towers on the south facade. As the water droplets fall within the shower tower, they evaporate slightly, which uses up energy. This process gradually cools the water droplets as it falls. The water sprays it into the plaza on the ground floor for cooling the space. The northern envelope consists of ventilation stacks and balconies. The stacks are smaller with wind turbines on the top. Also, they absorb the heat from the northern sun. All these characters contribute to perfect ventilation. In addition, the thickness of the stacks contributes to diffusing the sunlight. The foliage in the balconies protects the building from the sun, filters sunlight, and reduces indoor glares. This perforated sheet metal facade is not only aesthetically pleasing, but also serves as practical function, providing privacy by reducing the ability to see in front from the street, while still allowing natural light and wind into the workspace. During the day, the perforated screen helps draw in a softer light by diminishing heat and glare from the sun. During the night, the backlit screen is warm and seems almost lantern-like. The climate control system of Council House 2 is quite smart and effective. Its working mode responds differently and effectively during the day and nighttime. In the early morning from 1 to 6 a.m., windows automatically open to allow in night air to cool down both the building's concrete structure and precast concrete ceiling panels. The coolant is stored in the thermal ceiling panels. Once the occupants arrive in the morning, air handling units on the roof kick off and supply filtered 100% outdoor air to cast concrete ducts running down the building's south elevation. The air, which is treated for humidity depending on the wet bulb temperature of the outside air, enters the space via floor-mounted, user-controlled twist diffusers at each workstation. This cool air heats up and rises through the space and pulled into the slots along the ceiling panels and into cavities where it exhausts into shaft designed in the northern elevation. These shafts exhaust through rooftop-mounted wind turbines. This combination of night flushing, thermal mass, and mechanically supplied fresh air has been more than enough to keep occupants cool the entire morning and on milder days well into the afternoon. During warm afternoons, radiant panels attached in the underside of the precast concrete ceiling units cool down the space. The beams are supplied with chilled water from two sources, an innovative phase change material-based storage tank in the basement, and a more conventional rooftop central plant consisting of a gas-fired cogeneration plant. During the night, water cascades across the shower tower and the south facade, cooled by night air and recycled back to help freeze phase change material in the basement. This is the mechanic details of the climate control system. The vaulted ceiling provides relatively large space, and in this way, it can store more coolant at night and heat during the daytime. It can also duct the waste warm air to the stacks on the north facade. On the west, the louvers are designed to control the light. In the afternoon, they are closed to block the western light. During the rest of the day, it's open to let the air and light in. In the northern facade, the green balcony provides the shading, while the light shelf also protects building from sun glare. It also bounces the light into the ceiling, and the light comes off into the interior from the gap between the undulating concrete panels. On the facades, the terrace, green balcony, and the stacks cast shadows. One of the central principles of ecologically sustainable development framework is to reduce energy consumption. Using daylight effectively as a primary light source in office spaces goes a very long way towards meeting this goal. Based on recent research, In the longer term, working predominantly under artificial light can have negative physiological and psychological impacts on our biological clock and natural health. The CH2 has a highly integrated system. The structural and enclosure systems are connected. The structural and passive climate control systems are united. The structural and artificial lighting systems are meshed. The structural and natural lighting systems are united. The enclosure and the passive climate control systems are united. The enclosure and artificial lighting systems are remote. The enclosure and natural lighting systems are united. The active climate control and structural systems are meshed. The active climate control and enclosure systems are united. The active climate control and artificial lighting systems are remote. The active climate control systems and the natural lighting are united. The western envelope is unified with the lighting system. The operable timber louvers, which adjust their angles automatically, maximize the indoor natural light and prevent glare as well. The northern facade is unified with lighting system because the foliage in the balconies protect the buildings from the sun. For the northern envelope, it is unified with the climate control. The stacks absorb the heat from the northern sun, heat the inside air, thus improving the ventilation via the wind turbines. Also, the southern envelope is connected with the climate control. The showering towers, which cool the recycling water at night, are anchored at the southern wall. The vaulted ceiling panels are also effective in the passive climate control. Fresh air supply from the floor rises up into the ceiling. The volume provided by the vault stores the air rising up from the floor and naturally leads to the air that goes up. The chilled panels are meshed with ceiling. The tube ties into chilled water supply, and the return lines are running in the cavities behind the precast concrete panels. In active mode, the chilled beams operate and cool down the air supplied from the floor. The natural lighting and structures are unified. The undulating concrete panel on the ceiling as a part of the structure also play important roles in the lighting. The north light bounced into the ceiling first and then bounced back into the interior. Artificial light and structures are meshed. The lamps are installed between the concrete panels. The natural lighting and passive climate control systems are unified. The louvers in the west closed at afternoon to avoid western light, and this way, the interior temperature is not going to be too high. Thanks for watching.